Hello everyone, I am Dr. Godundaraman. In this section we are going to discuss with harmonic function, conjugate harmonic function, f of z type of problem. Look at this problem, show that the function u equal to 1 by 2 log of x square plus y square is a harmonic and determine its conjugate, also find f of z. Now first of all, u is given, now should prove harmonic. When it's a harmonic, the given function satisfying this Laplace equation, then the function is harmonic function. Therefore, what is the Laplace equation? Laplace equation, u is given, then uxx plus uyy equal to 0. Uxx is nothing but dou square u by dou x square dou square u by dou y square equal to 0. So this is a Laplace equation. The function satisfying this Laplace equation, the given function is harmonic function. Now given u equal to 1 by 2 log of x square y square. Now differentiate to consider this equation number 1. Differentiate 1 partially with respect to x. Therefore, when I differentiate x, ux equal to 1 by 2 constant, d by dx of log x, differentiation of log x 1 by x. Therefore, this differentiation log of x square y square differentiation 1 by x square plus y square. Now we have done the differentiation, the entire part, log of x differentiation 1 by x square plus y square, and then again to differentiate the variable. Which variable? This part, overall differentiation and only the variable differentiation, x square y square differentiation 2x plus 0. Now 1 by 2 1 by x square y square into 2x. To cancel this 2 and this 2, therefore ux value is nothing but x by x square plus y square. To consider, this is the equation number 2. Then again differentiate equation 2 partially with respect to x. Now d by dx of u by v is nothing but vu dash minus uv dash by v square. Therefore uxx equal to v. What is a v? Denominator value v, x square y square. The numerator differentiation with respect to x differentiation 1 minus x v dash 2x plus 0, x square differentiation 2x, then y square constant 0, divided by x square y square whole square. And now x square plus y square minus 2x square divided by x square y square whole square. From this simplification, x square minus 2x square is nothing but minus x square, y square minus x square divided by x square plus y square whole square uxx. Now this is the equation 3 to consider. This is the equation number 3. And then next equation, u differentiate 1 partially with respect to y. So u equal to 1 by 2 log of x square y square differentiate with respect to y, uy equal to 1 by 2 constant log of x differentiation x square plus y square into the variable differentiation 0 plus 2y. To cancel this 2 and this 2, now y by x square y square, this is a uy. Now equation number 4. Now differentiate again 4 partially with respect to y. U y equal to u by v form. So v x square y square u dash y differentiation 1 minus u y v dash 0 plus 2y divided by v square x square y square whole square. Therefore x square y square minus 2y square divided by x square y square whole square. To simplify this term, x square minus y square divided by x square plus y square whole square. Now to consider, this is a uyy. Now this is the equation number 5. Adding equation 3 and 5, uxx plus uyy equal to y square minus x square divided by x square y square whole square plus x square minus y square divided by x square plus y square whole square. When the denominator equal, then we can add numerator value. So y square minus x square plus x square minus y square divided by x square y square whole square. Now to cancel this term, therefore 0 uxx uyy. So when 0 uxx plus uyy 0, then Laplace equation is satisfied. If the Laplace equation is satisfied, therefore the given u function is harmonic function. So what is the next question? Find conjugate harmonic and then f of z. So I mentioned earlier the previous video. Now the way is nothing but, if suppose f of z, first of all u given, now the conjugate is nothing but 2v to calculate, then f of z u plus iv, then to simplify in terms of z. So this is a one method. Method 1, u given, from the u direct formula v is there. So v is a conjugate, using the formula to calculate v. Then u plus v substitute f of z. Then method 2, u is given, from this u find f of z, then to simplify f of z find the v value. And method 3, u given, now find f of z, find v. So this is a separate formula. This f of z separate formula, then v to calculate separate formula. Now I am going to apply with method 2. What is the method 2? U given. First to find f of z. How to find f of z? See, to find f of z using Milne-Thomson method. So Milne-Thomson method is nothing but to find f of z when u is given. When u is given, f of z equal to integral pi 1 of z comma 0 dz minus I into pi 2 of z comma 0 dz, where pi 1 of z comma 0 is nothing but ux of z comma 0, pi 2 of z comma 0 is nothing but uy of z comma 0. So this is a form. Now here pi 1 of z comma 0 to calculate. So pi 1 of z comma 0 is nothing but ux of z comma 0. So ux of ux of z comma 0, ux value x by x square plus y square, x by x square plus y square. Then substitute z comma 0, where x substitute z, where y substitute 0. Therefore z by z square plus 0 square, then z by z square, to cancel this z, 1 by z, 1 by z. So pi 1 of z comma 0 equal to ux of z comma 0. This is a pi 1 of z comma 0. And then pi 2 of z comma 0, uy of z comma 0. Uy value y by x square plus y square, y by x square plus y square, z comma 0 to substitute. So where x substitute z, where y substitute 0. When I substituted this term, 0 by z square plus 0, so whole term 0. Pi 2 of z comma 0 equal to uy of z comma 0. Now substitute this value, f of z integral pi 1 of z comma 0 dz minus I into pi 2 of z comma 0 dz, to substitute this term 1 by z dz minus I into 0. So this integration of dz by z minus 0. dz by z is nothing but log z plus constant. So this is a f of z value. F of z is nothing but log z. Now from this equation f of z, now we have to complete it. U is a harmonic, then f of z. Next, to find the value of v, to find the value of v, to find conjugate harmonic v, to calculate. Therefore here z equal to x plus iy, then f of z equal to u plus iv. So therefore to substitute here x value and f of z value, f of z equal to log z plus constant, f of z u plus iv equal to log of x plus iy plus constant. From this equation, log of x plus iy is nothing but, we know the value, log of x square plus y square square root plus I into tan inverse of y by x plus this c should write c1 plus ic2 u plus iv. Now real and imaginary, because of real part, imaginary part, based on that we are going to calculate. This is a form. Now here square root, when to remove here, 1 by 2 log of x square plus y square plus c1 plus I into tan inverse of y by x plus c2. So this is a real and imaginary. Therefore now to find the imaginary part, imaginary is what? So comparing real and imaginary, u equal to 1 by 2 log x square. So v equal to, from this equation to write the imaginary part. So equating the imaginary part. Therefore v equal to tan inverse of y by x plus c2. Thank you.